like, even just take something like this. And you want to take the derivative of it. Can you, instead of using quotient rule, say, can you take the top, bring it to the top as a negative power, and use product rule instead? And the answer is kind of yes, but there's a trick that if you don't know, you'll mess it up. And it's called chain rule. And the basic idea of chain rule is this. I'll write it up this way. Not like that. If you have a function that is a function within another function, do you know what that's called when it's one within another?
Composition.
Composition. So if you have a function within another function, like this is kind of like a division function or whatever, and then I have 3x squared at the bottom of it. So I have like one thing within another. I have to use something called chain rule. And to take the derivative with chain rule, what we do is we take the derivative of the outermost thing with respect to what's ever inside, and then we multiply the whole thing by the derivative of the thing that was inside. So if you have a function and it's something within another function, it's important to identify what's inside and what's outside. Because what you're going to do is you're going to take the derivative of whatever function's outside with respect to what's in. You're going to leave the inside thing alone. And then you multiply the whole thing by the derivative of what was in there in the first place. So if I had something like this, and I wanted to bring the bottom up like this, I can. But what I have happening here is I've got a power happening, and I've got the inside happening. So I actually don't need product rule. For this one, I can use power rule. I can take the negative 1 times the 2, leave this alone, 3x squared minus 1, subtract 1 from the power. So far nothing has changed. This is like the inside thing. So I've taken the power to the front, left this alone, changed the power. But then I have to multiply by the derivative of the stuff I've underlined in black. So 6x. And that's why when we first did the definition of a derivative, when we had like the square root of like 2x or something, you couldn't just use the shortcut because there was a chain that was happening that you didn't know about. So for this particular problem, you would clean it up a little bit. You've got a negative 2 times a 6x on the top of this fraction. And on the bottom, I've got 3x squared minus 1 quantity squared. Is that okay? I know, it's crazy. So like, let's say this one. If you want to take the derivative of this, I actually have 2 choices. Choice number 1 would be leave it as it is, and we're going to use the power rule with the chain rule. So the derivative would be 4 to the front times all of this left alone to the third, and then I got to chain on the derivative of this whole thing that's inside. So what do you need to chain? What do you need to use to take that derivative? Quotient rule. So since it's a quotient, now I'm going to go the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Right? So this would be with like power and chain rule. Or you could do it is do 5x plus 3 to the 4th over 2x minus 1 to the 4th and use quotient rule first. Am I going too fast? Okay.
I just have a question.
Yeah, go ahead.
After you did the quotient rule, what happened to the
This was the quotient rule of the inside stuff, and it's like I don't need to use those powers anymore. So what I'm doing is I'm taking the derivative of the outside, meaning like the 4th. So that derivative requires me bringing down the 4, putting this down and subtracting 1 from this, and then I gotta multiply on the derivative of this, and that's what this is. No big power anymore. It's like its own little thing. Big thing. So the other way I could have done it was, from the beginning, I could have split up that power and applied it to the top and bottom and used quotient rule. And I could say it's the bottom times the derivative of the top. But the derivative of this top is another chain rule problem. Because the derivative of this top requires I take the 4 to the front, put down what's here, subtract 1 from the power, and chain on the derivative of the inside thing. I'm still not even close to done. Wait, what? Just we're done. Calculus over. Minus, that's just the Hody high. Now I've got the high. D ho. The derivative of the ho is 4 times 2x minus 1 to the 3rd times what? 2. All over 2x minus 1 to the 4th squared.
Why?
Because that's the ho-ho.
Why do we do this?
Yes, this is possible. You have to do this. This isn't like a bar out there question.
We should have one test with just one question.
That would suck.
Yeah, right.
Yeah, if you get it wrong, you get a 0.
Oh, that's how you get it right. It takes 45 minutes.
Yeah.
Could you make the denominator into a negative exponent and just go 1 to the chain rule?
You could go right to the product rule that you'd also use the chain rule for. So you have a third option.
Stop it.
This is using.
No more.
My third way.
Going back to the second way before we
Oh,
jump
yeah,
ahead
go
of
ahead.
ourselves. Match up the Hody highs and the Hody ho's.
Okay, ready? Let me get it. I'll use a different color. Just
Ooh.
So here's a ho.
Right. We're right
Here is the derivative of the high.
One.
Here's a high. Here is a derivative of a ho. And this is a ho-ho. Because the derivative of the high needs 4 to the front, write this down, subtract 1, times the derivative of 5x minus plus 3 is 5.
Okay.
Don't hate the messenger. Don't make this stuff up.
Who made it up?
Why do we have to
Your mother.
Huh. She was not a good at math.
See, that's why I can't be filmed. If there are jokes that can't be expressed, I feel